Welcome to today's webinar. The topic for today is I'm non-compliant with California AB 2511. Now what? My name is Brody Coates. I'm a senior building consultant at Direct Supply, and I will be hosting today's presentation. As a reminder, this webinar is intended to provide general information, but not legal advice. We have a great expert joining us today, and I'm honored to introduce him. John Sharpe is a National Power Solutions Manager for Generac Industrial Power. He is a graduate of Virginia Tech in Industrial and Systems Engineer. He spent the first 20 years of his career working in Caterpillar dealer network in Virginia, North Carolina, and Arizona. With power generation as the basis of his work, John has filled many roles within the dealerships, including project management, sales engineer, rental manager, and operations manager. He is also a certified Six Sigma Black Belt for process improvement and holds certifications in data center design. John joined Generac in 2012 and is our National Power Solutions Manager. He has been a member of the American Society of Healthcare Engineers and North Carolina and Florida Healthcare Engineering Association. John also represents Generac and Electrical Generating Systems Association on the NFPA 110-111 Technical Committee. John, I'll turn it over to you.
Thanks, Brody. Welcome to everyone here. And we'll pop these slides up and we'll go from here. So thank you everyone for joining us today. This presentation again is going to be talking about AB 2511 and some of the similar things that we've seen in other places across the country, what we've seen other people do, and some tips and things to have a conversation about what you want to accomplish. Understand AB 2511 and what was the intent or what's going on with AB 2511. The rule is there for resident safety, right? The rule says that skilled nursing facilities have to be able to maintain safe temperatures for the residents. And safe temperatures are going to be between 71 and 81 degrees, right? That is the rule that we have to have. And for this rule, not only do we have to maintain a safe temperature, we have to be able to prepare to have that safe temperature for up to 96 hours. So that's 4 days that you have to be able to maintain that. So for a loss of power, for any sort of a natural disaster or anything that goes on, the facility has to be able to maintain safe temperature for all the residents for up to 96 hours. Okay. For those of you thinking about that, all right, well, 96 hours, that's 4 days. I've only got, what do I have today? I got the generator out back, right? Well, the rule states that you have a generator out back today. That generator backs up what we call your essential systems, right? And the essential systems are what we're going to call life safety equipment that's there in the facility. That's all spelled out in the code, the California Electrical Code. We have to increase what is a 6-hour window of that generator up to 96 hours. Plus, again, have to back up the rest of the heating and cooling for all of 96 hours. The challenge is that HCI put this out and said that this deadline to have all of this in place was January 1st of 2024, which if I'm looking at the calendar tells me that was 3 months ago. And at this point in time, per CAF, they're saying that virtually all skilled nursing facilities have received citations based on 2024 surveys, right? So you weren't given a great deal of time to address this. Okay, so you're not alone in that. I want to be very clear. One, obviously, there are many of you in California that are dealing with this. Most of you are considered non-compliant by the state today. And this is not unusual from what other states have done. We'll talk about that in a moment. But you want to say, how did we get here, right? So this is not a new thing, right? This may be new to you, but you understand that there is a nationwide conversation regarding resident safety. And it's a temperature driven, right? Just for context, I live in North Carolina, but I'm fortunate I live in the mountains of North Carolina. But you get on the coast of North Carolina where we have high likelihoods of things like hurricanes, that becomes a concern, right? Obviously, previous states have gotten into asking for these type of requirements as well, or mandating these types of requirements for skilled nursing homes, for assisted living facilities within their jurisdiction. they're having the conversation that says that temperature in the building is just as important as food and water, lights and oxygen, all the other things that you already are required to have today for the residents in the facility. And this is all primarily weather driven. Um, Hurricane Hillary, I believe that was a hurricane that you just had in California. Was it earlier this year or late last year? That starts to make you aware that these things can happen. But of course, California, you have earthquakes. We've just had huge snowstorms. You have wildfires. You have public safety power shutoffs, which is something many of us aren't familiar with, but I'm sure you're intimately familiar with. Those all can go on and last hours and days. And making sure that resident safety is taken care of is the mission of these types of regulations. Okay. Is there a precedent? As I said, this is not completely new. I'm going to speak for a moment about Florida and what happened in Florida. I'm I don't know that fortunate is the word, but I was fortunate enough to participate in the Florida event that was very similar to this. So those of you that are familiar, in 2017, Hurricane Irma struck the state of Florida. Irma was a challenge of a hurricane. Although the people of Florida are pretty good at figuring out where it's going to land, we didn't know for several days where Hurricane Irma was going to land. And ultimately, it went straight up the state. Within Miami, or just outside of Miami, in the town of Hollywood, Florida, which is just north of Miami, there was a skilled nursing facility that lost power, and it reached 99 degrees inside that skilled nursing facility. And as a result of that event, they did not have power for, I believe, it was up to 3 days that they did not have power at that facility. And the temperature got to be 99 degrees, and 12 residents passed because of that. I believe 8 of them passed directly as a part as at the facility. The others were taken to the hospital afterwards and passed as a complication from being in 99-degree weather for 3 days. Um, the sad part about that is the unfortunate part about that is that that skilled nursing facility, one, had a generator on site, um, and had the ability to put their air conditioning on the generator, but no one understood how. They'd had a circuit breaker trip. Additionally, that skilled nursing facility is directly across the road from a hospital, a major hospital. They could have taken those patients there. The problem was no one came to work. It's rather difficult to get people to leave their family and their homes and come into work after a hurricane has come through. Uh, because of these complications, the governor of Florida worked with the legislation, passed a rule. And when they passed that rule, they did much to what you're seeing in California. They gave a 9-month implementation to be able to bring the air conditioning online, right? So what they're saying is you had to have 96 hours of support for air conditioning, right? And for the people of Florida, this was considered an unfunded mandate. It required the skilled nursing facilities and the administrators, such as yourself, to complete an emergency power plan and a comprehensive emergency as part of their comprehensive emergency management plan. So this is very similar to what you're doing in California, is that they're having to fill out a documentation saying, hey, well, what am I going to do to make sure that I have air conditioning so that we don't have these particular issues? And again, the 96 hours becomes a trigger. There were 1,700 facilities that were impacted. I believe 1,200 assisted living and 500 and some skilled nursing facilities in Florida. And initially within 9 months, no one was compliant because construction schedules just weren't going to be met for that. And it took 40% of them had filled out their documentation to the point where they had a big enough generator to deal with they could deal with. But took 3 years to get to close to full compliance within the state of Florida for all of the skilled nursing and assisted living facilities in the state of Florida. So this was a rather large event. But I want to just demonstrate to you that there's a precedent for what you're going through now that other people have gone through previously. And this is part of a national conversation. I understand the state of Louisiana has looked at this. Texas has looked at this. My state of North Carolina has looked at it. Indiana has looked at it. So there are a number of states that are looking at doing this type of legislation to protect residences in skilled nursing and assisted living facilities. I understand California is just for skilled nursing, but in this particular state, assisted living was also there. In this presentation, I want to talk about a few different things here. So I want to talk a bit about plan of correction and assessments, get into alternative source options, right? What are your choices? What happens? What can you do to make this happen? Um, Talk about equipment, talk about some local codes, a bit about the project itself. How long is this going to take? Who can you talk to? Right? And they're going to give you some examples of some challenges in the design, right? Things maybe not to do, and some real world examples to tell you what other folks have done. Because again, this is legislation that's kind of moving around the country, and you're going to see many people in different states ultimately deal with these types of issues. So I wanted to make sure that you're familiar with that. All right, sliding in here. So perform an assessment, right? So what the state is asking you to do initially is that you need to do an assessment to understand where you are today. Okay. And some of you may actually be compliant if you have all the correct equipment and large enough equipment to do so. I'm going to be frank with you, it's probably unlikely that you are because the new requirements are asking for not only additional components that need to be put on your backup system, but also that extending that runtime for 96 hours becomes a point of conversation. Um, but first thing you need to do is you need to walk through the facility and understand what you have, what type of heating do you have in the facility, what type of cooling do you have. Again, we're dealing with defibrillators, crash carts, and all of that. And we need to show what's on your essential systems or emergency power today so that they understand what is our scope today and what is our scope to be, right? Because then during this assessment, you're going to have to show some sort of a floor plan that says, like, this is where our air conditioners are, this is where our electrical room is, this is where our heating is. You're going to be able to show a floor plan that says these are the areas that we're cooling. I do want to be very clear about this, and I've read this in a number of different documents from the HCI folks. You can't just create some sort of a cooling and heating island, right? Like, hey, let's just make the dining room the place to be. Okay, and then it will move everyone to the dining room. That's not an acceptable thing. They are saying that you do not have to have every square inch of the facility taken care of temperature wise, but they're not going to let you just create an island that then has to move the residences out. In general, the facility needs to maintain the temperature. That's the principle or the guideline that they're giving you. Okay. And from this assessment, you're going to look and see, well, these are our air conditioning units. These are our heating units. This is what's hooked up to the generator today. This is the areas that they're being served, right, with a floor plan. You're going to have to do what we call an electrical single line diagram. And this is probably where you're going to have to start thinking about bringing in a professional. And we'll talk about that in a little while. I'm going to show you some single line diagrams. I'm going to try to keep it at a very high level so you understand that. But you will have to demonstrate, okay, this is where things are today. And if we're going to make changes, if we're going to have a remediation plan to get us under compliance, how do we modify that one line so that the power goes where it needs to? And who's going to do that type of work? Okay. So one place that you can go to get a lot of information is to look at this particular link here. This is to the HCI site. Um, and this gives you the instructions on how to do the assessments, right? It's an online assessment that has to be done. Okay, there's just a quick shot here of the assessment and what they're looking for here. This is done on their online system, right? So there's a questionnaire where they're going to ask you a lot of questions about your heating and your cooling. They're going to ask you questions about the electrical in your facility, right? So you're going to go to that site, you're going to fill out this online assessment, and you're going to tell them, hey, this is what we plan on doing. That's part of the assessment, right? So here's where I am today. I'm non-compliant. And this is the plan for us in general to be able to become compliant, right? Be it adding additional generator, enlarging the generator you have, adding a second breaker. Again, I'll talk all about that, getting a bigger fuel tank, putting in a microgrid system, whatever it is, you need to spell that out as a part of the assessment. And then one thing to point out here is this is the MOU, right? This is the Memorandum of Understanding. They're pretty explicit in their instructions from the state. And again, I'll talk a little bit about this, but how is it that you're going to get to 96 hours? 96 hours of fuel is a lot of fuel. 96 hours of battery is a tremendous amount of battery. How are you going to get to 96 hours? What is the plan there? Okay. Um, HCI is going to review it And they're going to say, hey, listen, if you're already in good, they're good. They're going to close out that assessment and you're fine. If you are not compliant, and again, most of you are not compliant, at this point, they're going to say, all right, this is your plan. We're okay with what your plan is. They're going to close out that assessment. You're going to then have to create a new construction plan, right? Most of you should be familiar with that, right? So you're going to have to do a whole new construction plan, submit that to HCI saying this is what we have to have. And in that, you're going to have finalized drawings from engineers. You're going to have to understand, what is it that we're doing and spell everything out that you're going to do and get HCI to buy into what is your new construction plan. Once you've completed that construction, however long that's going to take, at that point, then you're going to have to do an assessment again, right? So the assessment is like a snapshot that says, where am I right now? And so right now, again, we're non-compliant. You do your construction project, you believe you're in compliance, you need to do an assessment again and have them review that. And as long as your project worked out and that everything is going to be taken care of, then they're going to complete your assessment, approve your assessment, and everything's fine. If they review it and not, then you're going to have another construction project. Okay, just so the reality of how this is going to go, it's assessment, construction, assessment. Okay, that's the plan that they're looking for. Is each time you need to get through a complete assessment that's approved before you can walk away from this particular rule. All right. I'm going to talk a little bit about three different scenarios, and I'm going to show you some one-lines on this, right? But again, I'll try to keep it at a pretty high level. Also going to show you some things that the state had put together in previous webinars and in their documentation that they've published, so that we're kind of consistent with what they're talking about. Three different options that I see that you can deal with. Um, the first is you have an existing generator. Every one of you has an existing generator, right? The code requires, both California Electrical Code as well as CMS requirements, that you have essential systems within the facility backed up by a generator. And so those are spelled out, right? And that's egress lighting and things along those lines, oxygen, the red plugs in the room, those things. So maybe your solution is we just need to add some additional loads to the existing generator and we're in good shape. And then we've got to do a memorandum of understanding and somehow address how we're dealing with 96 hours of operation. Okay. Another solution could be that you're going to add a new or an additional generator. So I could take the generator I've got and I could take that generator, maybe add a little bit of load to it, and I'll show you how that works, and we'll be good. Or I could replace that with a little bit bigger one that then could add some load to, and I'd be in pretty good shape. Um, or I could add a completely different generator to the facility, right? And this could be the generator that either takes care of these newly mandated loads, right? So you'd size up how that has to be, how big of a generator do I have, and make sure that that generator just carries these particular loads and good for 96 hours. Do understand though, I'll bring this up a number of times, if you bring in a new generator to take care of these newly mandated loads, do recognize that the existing generator still has to be upgraded or you have to have provisions for 96 hours for that generator because we can't now just be running the air conditioning for 96 hours, but we don't have life safety loads or essential system loads backed up for 96 hours. They both have to be available for 96 hours. The third solution regarding new generator would be to go ahead and maybe bring in, and I'll talk a little bit about this, is to just show a whole house generator, right? Let's just bring in not one generator that takes care of these newly mandated loads, but maybe we just bring in a generator that backs up the whole building. Okay, and I'll talk about a little pluses and minuses of how to do that. Lastly, you could talk about maybe a new microgrid, right? All of the documentation that you're seeing from HCI regarding this particular rule, it talks about alternative sources, alternative sources of fuel. I'm sorry, alternative sources of power. And alternative sources don't have to be generators, right? They can be turbines, fuel cells, you can have battery storage, you can have solar, a number of things you can have there. So I want to talk a little bit about those as well. Okay, this is what I believe you have today. Okay. Based on everything that I've read, understanding the California codes, many of you are going to have it. So this is a pretty simplified one line, right? Where you have a utility power that's coming in. And from that utility power, you can then have the power that comes into the main service disconnect. Your power breaks into a couple different branches at that point based on code requirements. There are certain loads in the facility that are known as life safety or essential systems. Okay. Essential systems in this particular case covers actually both transfer switches. Let me get that straight. So one, you have a life safety transfer switch. And as I mentioned, that's your red plugs, that's your egress lighting, that is medical refrigeration, communications, fire alarm, right? Those are all code required that you have to have. So you need to have a generator that backs those things up. And those frankly, outside of red plugs, those are things that you typically see in every building. Every building that's occupied by common people, has to have fire alarm, communication, and egress lighting backed up by a life safety generator. Um, Additionally, medical here, we're talking about red plugs and medical refrigeration. Also, you have to back up equipment loads. And equipment loads, in particular case of California, requires heating for the patient rooms, patient care spaces, right? The pharmacy, the nurse's station, those all have to be backed up as well. One thing I want to point out to you here is please notice that there are two different devices here that are called automatic transfer switches. Okay. There's one that's up here to the upper right. There's one here in the middle. Okay. Code requires that you separate those loads. Okay. That's just a code that's done nationally per the National Electric Code, is that things that are taken care of on the life safety side have to be separated from things that are taken care of the equipment side. Because if something happens on the equipment side, we want to make sure we have what's called separation of circuits. So that's why you have two transfer switches to carry those loads. And frankly, this may mean that you're in better shape than you think, right? This is what we need to figure out through your assessment, because many facilities in many other states simply have a life safety generator that covers life safety loads, and you don't even have the second switch in place. You don't have the equipment being carried. This is something that's within your particular state. All right, I'm going to bump over here to see, so what is a solution that's got to be had? Well, the simplest solution, if you're fortunate, is that we take this green box here, the site HVAC loads, this heating, ventilating, air conditioning loads, right? The air conditioning loads, and that you tie those to the output of the equipment transfer switch, right? So you separate those air conditioning loads and you tie them to the equipment loads. Okay. The question is going to be, when you do this, is the generator that you have on site, is the generator large enough to carry those additional loads? Is the transfer switch that is feeding now the equipment and HVAC loads large enough to handle those loads? Is the circuit breaker on the generator large enough to do so? So those are a couple things that you're going to have to check out in the assessment is, do we have enough power to now back up all of these additional loads without having to do a whole lot of work, right? Or you hope not a whole lot of work. Okay. So one of the cases I talked about was maybe that you have to just replace this generator with a larger generator. Okay. So best case scenario is you don't have to replace this generator at all. We just got to add some loads to it and figure out the fuel thing. Um, Second best scenario is I add the air conditioning to it, and maybe I need to put in a larger generator, which again, I would have to deal with the fuel, but I can put in a larger generator, and now all my loads are good, and the construction project is less of a scope. Um, but that's what you need to determine with the assessment is how much additional load I be putting on the piece of equipment. Like, what equipment do I have? Right. Part of the assessment is how big of a generator do I have? And the second is, if I add these loads now, is this generator large enough to handle those additional loads that weren't planned for on day one when that generator was put in? I'm going to slip over to this slide right here. This is the same conversation. I want you just to be familiar with this one line that was done by the state. And so you can see what they're pointing out here, where they're saying, right, they're going to take this HVAC load that's over here on the left and rewire it over to this equipment transfer switch. So in that particular case, you're going to need an electrical contractor to come in to be able to do the rewiring. One thing about rewiring, and I want to bring this up a little bit here, is you need to understand where is the power feeding the type of HVAC you have in the facility. Do you have centralized HVAC, Or do you have distributed HVAC, right? If you're familiar with the term PTAC, right, which is the air conditioning units that you may see in some where you have the individual air conditioning units in every residence's room. Okay. If you have those, they're all wired back to a central point, right? Or are they wired back to multiple central points? Because then you'd have to move all the power from all of those over here to that equipment transfer switch. So that's a conversation that you're going to have is, hey, what kind of air conditioning do I have? And where does it get its power? I'll give you a quick example from a facility that I worked with on a project. Um, they were a square building and they had PTAC units in everyone's rooms. The challenge was every hall had its own electrical panel. So I wasn't just moving the air conditioning from one group over to another from an electrical standpoint, but I was having to re-engineer everything to where we were pulling all the air conditioner electricity from 4 different electrical rooms that didn't have the space to play with, rewire those all the way back to a central point to be able to tie those, right? And that was what I'm going to call a very intrusive process. We had to tear that out pretty hard. Okay. Moving on here, I want to speak to the other option of maybe that I get a new generator, right? So maybe we've determined during the assessment that the on-site generator that you have today is not large enough for what you're going to be adding to the facility, right? And it just have to understand your facility, understand what those loads are. And it may be that we need to just add an additional generator to the facility to take care of these newly mandated loads. Okay, so taking care of those, now it's a matter of someone has to take the assessment, understand how much power it is it's going to be required for these newly mandated loads, and be able to put in a new generator strictly for those loads, right? So that's a new generator, that's a new automatic transfer switch, and that's where you're going to rewire these air conditioning to a separate panel that can be backed up by that automatic transfer switch. So new gen, new switch, new panel that everything's being rewired to. So kind of intrusive inside the building, but you're also putting new equipment into there. Okay. When you do something along these lines, like I said, if you're going to add an additional generator to the facility, do recognize again that that doesn't get you off the hook for the life safety generator. You still have to have the life safety generator up to 96 hours. Whatever memorandum of understanding, whatever plan you have, you still have to have the life safety boosted up to 96 hours of available runtime, as well as the new generator meeting the same. Okay, so this gets into the slide that they had shown us here from the HCI site, where they're saying, all right, again, these two one lines, the one I just showed you, the one I'm showing you now, essentially the same thing, but they're saying, hey, I'm going to drop in a new generator, right? And the new generator has to be available for 96 hours of fuel, and the existing generator has to be available for 96 hours of fuel. So there's some electrical rewiring in the facility that's got to be done. There's some new equipment that's got to be done. And then there's some modifications to the existing generator to deal with that. Okay. So one suggestion that I offer, and I'll show maybe if I have the time, I'll show you later about this, but um, some of the folks that we dealt with in previous projects went with the idea of why don't we just carry the whole building on a whole new generator? And I know you're looking at me, good looking guy, sells generators. You're saying, yeah, he just wants to sell big generators. And that's not my point at all. My point here is when you're dealing with the residences that you're dealing with, some of whom are going to be elderly, some of those who are going to be in a different level of safety than maybe everyone else in the general population, um, how much work do you want to do inside the facility? My example of having the 4 different walls and having to have all those electrical rooms rewired back to a single point. Like I said, that was rather intrusive, right? That was months of electricians going in and out of the facility, working every day. Um, I think one of the particular facilities we worked in had memory care issues. So now they had to be coded in and out all of the time because the patients weren't free to leave. So you had to make sure you had security on a regular basis. Um, Sometimes it's easier to take the expense away from all the rewiring and just buy a bigger piece of equipment and make all of the work on the outside, right? Or nearly all of the work on the outside. So what we talk about here is we talk about putting in a whole house generator. I'll mention a little bit about it in a minute, but in this particular case, what you'd have is you'd have one generator that backs up the whole building, right? You're going to interrupt the feed coming in from the utility. So that's on the top side of this, right? So I'm up here intercepting the feed, put in a new whole house transfer switch. And then when you lose power, the whole building goes on a new generator. Now, is this generator bigger than what we were talking about one slide back? Absolutely, right? So is this generator cost more? Yes, it does. But it's all a matter of degrees, right? You're already going to have a sunk cost of installing a generator, doing a lot of wiring, doing some electrical contractor work. The question is, do you want to spend more money and time inside rewiring your building or do most of this work outside? It's one of those pay me now, pay me laters where the money that you're going to spend on the installation is probably going to be close to what it would cost to just put in a bigger generator and not ever have to go in the building or not spend much time in the building at all, as opposed to what potentially could be months of work, right? So it's a question of, do I want to spend the money on electrical contracting and being in the building and rewiring the building, or do I want to spend the money on a little bit bigger generator and then carrying the entire facility, right? And that's the conversation you'd want to have with your design engineer who's going to help you with this, is saying, hey, what if I just put the whole building on there? Right? Still gonna have 96 hours, still with that, but now we've got a full back of the entire facility, and we're in pretty good shape from there. So that's one conversation to have, and I can't say that I could have told you that before everything happened in Florida and all the work that we did there. We did hundreds of generator installations in Florida, and a lot of those conversations were about, well, how big of a generator do I need to spend? Where I spend the money. One group decided they were going very intrusive, and they rewired all their buildings, and it took them months and months and months to do. Another group said, we're just going to buy whole house, and it made their life a good bit easier. And sure, they bought bigger generators, but they paid less in electrical contracting and pretty close to a wash at that point. So that's something to think about when you're talking to your design professional. The other option that you have here is to look at a microgrid solution. I know the state has talked a bit about this because, like I said, they don't require that this solution for AB 2518, or sorry, 2511, they don't require that this alternate power source is a generator at all, right? Like I said, it could be batteries, it can be solar, it can be all kinds of different other things. Um, the thing I want you to recognize, however, is that um, one, these solutions take up a lot of room. And real estate in California, from what I understand, I've read the papers once or twice, it says it's rather pricey. So that's a concern, especially if you're going to go with solar or what we call PV, which is photovoltaic systems, right? You're going to need either the entire roof of the facility or cover all the parking and put solar on there. You're going to need a lot of real estate to get enough photovoltaic solar to be able to back the system up. But PV doesn't get you anywhere, right? Challenge with PV is it's great from, I don't know, 9:30, 10 o'clock until 2, 3 o'clock in the afternoon. But as the sun starts to pass by and starts to set, you don't have as much power. So you have to add something like some battery storage or something to then store that energy and hold on to it to make sure that the solar is being able to be used, right? Because if you lose power at 10 o'clock at night, solar's getting you nowhere. The battery is then what you have to have. This BESS is what we call a battery energy storage system. Um, but then the challenge comes into the fact that you have to have 96 hours of support. 96 hours of battery, that is a lot of battery. Okay. Not saying it can't be done. Just recognize again that that's a lot of battery that's going to have to be replaced within probably 10 years. That is also just going to be a very expensive solution to begin with. It's going to take up a lot of footprint. So do pay attention to microgrid solutions. Nothing wrong with microgrid solutions, right? I work on those products every day. I just had a call about it 3 hours ago. It's just whether or not this suits you, there are a number of things you need to think about between expense, footprint, and everything along those lines, as well as they're going to tell you that they being HCI, that even if you put in this solution with solar and battery, and even if you have 96 hours of battery and enough power to back up the facility for 96 hours, you still have to have a connection to bring in a generator after 96 hours. So they're not only saying that you have to have 96 hours, you got to have 96 hours plus when it comes to the microgrid solution. So that's something that you do want to pay attention to. And again, I'm reading this, I didn't make the rules. I'm just reading what the documentation come from HCI that, they're all about doing this. That's great. It's a green solution. I'm a fan, but recognize there's additional limitations that are going to have to come in. So this again showing the state's slide of microgrid solutions and all the different things, fuel cells, photovoltaics, and all of that. Um, how do you handle the 96 hours is going to be one of the big challenges if you decide to go down a microgrid solution. Now, if you were in some sort of campus environment where you had some real estate and things along those lines, this may be a pretty good solution. But you need to talk to your design professional and maybe work up some of the economics of this to see if this is going to be feasible. All right. Lastly, about microgrids, I do want to talk about this. This is a very busy slide. Hopefully, you can download this. You'll look at it later, but someone's got to figure out where does the power come when, right? You have all of these different assets shown up in the upper left-hand corner, but you can see here this black line. This is how much power your building's pulling. The blue line is power from the utility. The pink line is the charge of the batteries, and the yellow line is from solar. Green from battery. So you can see that in the middle of the day, I get solar power. That's all great. But if solar dies off, I use the battery, this green area, to get me through. Okay. But how am I going to make sure that I can get my ride through all the way through for 96 hours? And that's a pretty steep challenge. All right. Going to get a little bit more about equipment. So I'm going to keep moving on here so we understand what we have. If you're going to do a generator, the state is a big fan of diesel, right? Or on-site fuel, and diesel is the most cost-effective on-site fuel. Um, Natural gas is not acceptable for skilled nursing facilities in California. I will tell you, if any of you were familiar with what happened back in the other state, um, in Florida, natural gas was acceptable to specifically address this particular load, right? You still had to have on-site fuel to take care of the essential systems, which is what you already have, right? But if you were adding a generator to take care of this load, a gas generator was perfectly fine. Or if you're doing a whole house generator, a gas generator is fine. But California, not a fan. Something about your earth shaking out there that they seem to be not a fan of. One thing I want to mention to you is going to be about how big of a fuel tank you're going to want to have. The tank that you're looking at there is at least a 48-hour tank, but I don't think it's bigger than a 72-hour tank. And you can see how big that is. So we need to think about how big of a tank do I want? One, the footprint, right? So the generator is going to get raised up, which means maybe now I have to have a platform. Okay, because code is going to require that once the tank is over 30 inches tall, you have to have an access platform for serviceability, right? So that becomes an additional expense, additional footprint, right? So if you're taking up a couple parking spaces, and I know people are pretty important about are pretty tied to their parking spaces. If you're giving them up, you may be giving up an extra one just on the working platform. But fuel doesn't last anymore. Diesel fuel doesn't last anymore. Way back in the day, uh, 20, 30 years ago, you could have diesel fuel and you had diesel generators and they could run off of anything. And it was black smoke and nobody cared and everything was fine. But with emissions rules today, we have much cleaner fuel and much cleaner generators. The impact of that, though, is that fuel is not storable like it used to be. And the diesel fuel, 1 to 2 years is about all you're going to get from the point they fill it up. You need to be done with it to fill it back up again, right? Because it's going to go bad. Chemically, it goes bad. It decomposes. Also, there's bacteria that grows in it that's going to cause issues with your generator. This quick chart here, and again, I won't read through it, but this was a 24-hour tank following standard um, recognized procedures for maintenance per NFPA 110, which you are required to follow. A 24-hour tank. So the concept of just putting 96 hours of fuel on site it's tough to do. Just going to be frank with you. Maybe get a 48-hour tank, and now we're talking about a memorandum of understanding and how you're going to get it supported. From a green standpoint, a couple things I want to mention. There's a product out in the industry these days called hydrotreated vegetable oil, right? This is the new clean diesel, perfectly good for this type of application. Okay. However, if you hear about biodiesel, right, you got those buses that run around town, they say, hey, I'm running on biodiesel. That's fantastic, except for this application. Biodiesel is even worse than regular diesel when it comes to storability. Biodiesel doesn't even make 6 months, right? We're talking about stuff that this is your fry grease, that type of thing, right? They've come up with biodiesel and they've taken regular diesel and they've added this additional grease and everything to it to make it a greener fuel. The problem is it is really, really unstable. It only lasts maybe 6 months. So in a stored system like this, not an option. No manufacturer is going to bless this for a long term, right? Everyone in this industry, not a fan. Um, Biodiesel is great for the bus because they burn it constantly running. They're constantly burning. It doesn't sit there for 9, 12, 15 months at a time. That's why biodiesel, bad, HVO, good. All right. Um, Liquefied propane is another option for fuel, right? It's going to be an on-site fuel. But one thing I do want to point out about liquefied propane is just like diesel fuel, in order to have 96 hours, we're talking a pretty big tank, right? Um, if you were to get a generator, a nominal size generator for what you're looking for, maybe a 150 kilowatt generator. I don't want to really get into how big that is, but that's a reasonable size generator for the solutions that we've seen in the past projects. You're going to need a 2,000 gallon tank. And this is a picture of a 2,000 gallon tank. Okay. That is a 5 foot around by 18-foot long tank. So it's much bigger than the generator itself. 150 kW generators, 3.5 feet wide by 12 feet long. So it's much bigger than the generator. Okay. But the other challenge here is to get 96 hours of fuel in this large enough tank. Code requires that you have to be at least 50 feet away from buildings and public ways, right? So now you can't put the generator. In this particular project we worked on, this was a little courtyard, right? And we had an LP solution, a liquefied propane solution. And we were able to put a tank in here because they were only putting in a 24-hour tank. But if you want to put in a 96-hour tank, once you break the threshold here of 2,000 gallons, it tells you you have to be 50 feet away from everything. As it is, if you're looking at like anything over, I think it's a 250 gallon tank, you've got to be 20 feet away from everything. So recognize that there are going to be some clearance issues depending on what solution is driven. And again, your professional, right? If you got a design professional, a PE that you're working with, they're going to know those rules. Um, Also recognize within your solution, I'm going to talk briefly about emissions. Um, Probably all know this, but there's 35 different air districts in the state of California, and everyone has their own rules. And some have become much more aggressive than others in cleaning the air, and justifiably so. Do not get me wrong. But in those rules, they have now impacted generator performance and generator emissions. And what I'm saying here is you see the Bay Area, Sacramento, San Joaquin, Santa Barbara. You're San Joaquin, right? What is this? 1/4 of the state, right? They're all requiring the super clean, what we call tier 4. I don't want to go into that, but um, super clean diesel generators. Doesn't matter the size, doesn't matter the location. So that generator is going to be more expensive, frankly, harder to get, longer lead time, just in those particular areas. Excuse me. I just want you to be aware of that. That's going to be an additional part of your conversation, right? As you go down the diesel road, that's probably the best solution. But in those particular areas, you're going to have the cleanest generator out there, right? So today's generator is very different than the generators we made just a few years ago to meet some of these rules. Additionally, we talk a little bit about seismic. Um, Everything you're going to read in the guidance from our folks at HCI is that anything that's added has to be seismic certified to take care of these loads. So that becomes a little bit of a challenge. That means the generator has to be seismically certified. That means if the generator is going to sit on a fuel tank, the generator and fuel tank as a pair have to be seismic certified. The transfer switch has to be certified. Any new electrical panels have to be certified. What I'm showing you right there is I'm going to go with a 300 kW generator on what is probably a 48-hour tank. All right, see how long that tank is to make 48 hours and stay under the footprint of the generator? That's on a shake table, right? So that is on a seismic shake table. That's one of our products that was seismically certified. So you can't just buy any generator and put it in there. We need to go ahead and make sure that it's seismically certified. And that means 96-hour tanks. Unlikely you're going to find one that's going to go under a generator that's going to make that happen. So do recognize it's got to be seismically certified. All right. A few other things I want to touch on here. Accessibility, space, right? Generators, the code requires that you have 3 feet of access, right? That's for safety for the person working on the piece of equipment. We as manufacturer are going to ask for at least 5 feet of clearance around it. So again, if you're sacrificing parking spaces, you're sticking it between buildings, um, pay attention to how big this is going to be and what kind of accessibility. We need 5 feet because we need airflow around the generator. 3 feet is for accessibility, safety. 5 feet is airflow so the generator doesn't overheat. And like I said, 96-hour fuel tank can be pretty long. Also, if you're adding a new transfer switch, you're going to be required to have 3 feet of space um, in front of the transfer switch. If you do a whole house solution, you might be more likely to find that 3 feet of space outside. All right. An automatic transfer switch. This is just a slide to make sure you all understand what this product is. This is the insides of a typical transfer switch. There's the generator, the utility, and the load all connect into this, and then the power goes out. This particular device here is what we call a service entrance transfer switch, a little bit more unique. Same switching mechanism here as it is on the other one, but there's also a circuit breaker from the utility coming in. Um, That's enough about equipment. Let's go back and just kind of sum this up here. What do you need to do next? And what you need to do next is you need to do an assessment. Um, that's going to take some time, right? And if you do have the staff that can help you with that, if not, who could you turn to? Because you're going to need to maybe reach out to the air conditioning and heating manufacturers to get documentation on exactly how much power is it going to take to run their equipment, because someone's going to have to then do some math to understand how big of a generator do you have to have. Also, do you have the existing one lines on the facility that you have? Um, the one line is going to be important to explain to the state how you're going to do what you're going to do. If you don't have those, you're going to need someone's going to have to recreate those, and typically that's going to be a professional engineer that does that. Do you have a relationship with a professional engineer? Right? Is there someone that's been doing some modifications to your building? Is that the right person for that? Also, electrical contractors, right? Do you have a relationship with an electrical contractor that can help you do new construction projects? Okay. Regarding new construction projects, I'm just going to kind of spell this out. You can look at this slide later. But you've got to hire engineers. We're talking about contractors. We're talking about HCI and how long it takes. Um, the generators, typical generators, are going to be somewhere up to 36 weeks to fit your need. Fuel tanks, depending on how big of a fuel tank, could be as much as 52 weeks. Transfer switches and electrical panels as electrical equipments can be about 20 weeks. So those just give you an idea of how long equipment is going to take. There are some long lead times on fuel tanks, long lead times on generators. A lot of that has to do with generator manufacturing as well as fuel tank and seismic and making sure that you get everything complete. Who can help you, right? When you're talking to an electrical contractor, make sure that this is somebody who's done all of this before, right? Uh, you can't just go to your regular electrical contractor for somebody that's just rewiring your building. Are they big enough in scope to be able to handle this type of equipment? Do they have the right construction equipment to dig and pour a pad and put the generator in place? Do you have an electrical engineer who is someone who's familiar with healthcare work, right? Are they familiar with HCI? Do they know HCI rules? Because they're going to submit documentation to local authorities as well as to the state. And it's nice if you got somebody who's talked to the state before. That's going to be very helpful, right? And then equipment wise, as I've shown a few things, make sure that it's something that is code compliant for state of California. Primarily what I'm saying there is you need to make sure that it's seismic, or if it's a diesel generator, that it meets the emissions rules of California. Okay. Common things that we see, right? Making sure that you follow up with all these standards. This isn't even 1/3 of all the standards that you could have to meet on this particular project. Um, but making sure that you have, don't choose equipment that's not certified for this application. Like I said, seismic and emissions. Choose installers that know what they're doing, right? That have done experience stuff. The guy that you're using today may be perfectly great for what they're doing, but this may be outside of their scope. So don't be talking to someone who's more of a maintenance electrician as opposed to someone who is a full-scale construction electrician. Making sure that you have equipment, right, that meets the 10-second start rules if you're going to be essential systems, that has all of these certifications. So make sure that you have equipment that's going to meet the need that's used commonly in these type of applications. You're like, oh yeah, we know about this. This has never happened. Well, I can tell you this happens. Um, Somebody didn't know what they were doing and poured a pad too small, right? This is a real project. Someone poured the pad too small. Here's an installer that decided that my flexible fuel line was really something to tie into a knot. I'm going to recommend that you don't do this. Here's an additional installer that hired somebody with not good enough crane straps, right? They lifted the generator up, they backed the truck up, the crane strap broke. just completely destroyed a generator, right? So while I'm recommending these things to you, and I know it sounds like, well, um, what we've got, yeah, we're going to know some people that know something. Make sure you've got contractors, engineers, and people who know how to do this type of work, right? At this point, I do want to make sure you've got notes here that says we're going to move on to a Q&A at this point. So if we want to move over to Brody, do you want to take over here? Last part of this is just a bunch of one-lines, which you can all use for reference. I have no issue there. Brody, do you want to step in? Where are we on this presentation?
Sure. Thanks, John. So it looks like the first question we have is, we're looking into a microgrid option or are concerned about the cost. What should we compare? What should we consider when comparing microgrids with generators? John, I'll turn that over to you. Do you got any input?
Yeah, costs, right? And I didn't really talk about costs, just to be all, you don't know me much, but I am more of an amps and volts person than dollars and cents, but I can give you a little bit of visibility here. One, a microgrid is not cheap in upfront cost. Battery energy storage is pretty expensive. Solar has dropped a lot, right? Big fan of solar. Solar panels have become much less expensive. If you follow that, you'll see in the industry where solar panels have become much less expensive. But there's a number of people have talked about whether or not you can apply for money through, CMS, whether you can apply for money through the Inflation Reduction Act or the Infrastructure Act. I can't really speak to those. That is not my thing. But I'm not aware of anything along the lines right now. So microgrid solutions are great, but they take up a lot of space and they're not cheap. So if this is an unfunded mandate and you're not going to find money anywhere else, that is one thing you do want to pay attention to, is that there's a good bit of cost that goes along with the microgrid solution, right?
Thanks, John. Let's see, the next question. It seems that the best solution is to have a bigger generator or a second generator as opposed to any microgrid system. Are the bigger generators available, and what is the lead time for a new generator?
And yeah, absolutely, bigger generators are available. And for the type and size of the buildings you're looking for here, I'd shown that on that slide. We're typically talking up to 36-week lead time for the piece of equipment. The key thing is you need to get an engineer in there that's going to help you do some sizing to understand how big of a generator you need, and then work with manufacturers on lead times. And certainly make sure that the state approves your plan before you decide to order that piece of equipment.
All right. Yeah, the other thing I'll just add to that too is, as you're going through this, you want to think about the other pieces of your facility that are going to be required throughout this. Just besides the loads that are going to be required per AB 2511, but you're still going to have to operate within that facility. So you're going to want to look at laundry and food service and everything else as um, you're going to be within that facility and need to stay there for that 96-hour period. Next question, my maintenance director is hearing we can save money by just adjusting and modifying the existing electrical and adding small secondary generator, non-FPA. Is this too good to be true?
Well, that's the question, right? And it's going to be different. That's what I spoke about before. Pay me now, pay me later, right? That may be a solution for some people. If you have your own internal electricians that can rewire the building and you don't mind them walking through the building weeks on end doing that kind of work, sure, that's one way to do it. And then you buy then you're buying a smaller piece of equipment, right? So less big capital expense, but there's a lot of the installation. But as we just talked about, Brody just mentioned, don't forget, you got to keep this place up and running, not only for long term, the 96 hours, right? All of the other things that you have to have, but you got to keep it running while all this construction is going on. And I know that getting electricians and contractors in there and working on things inside residences areas, that's a bear. So it may save you a little bit of money, and maybe you spend less on the generator and a little more on the contractor, but recognize that contractor, there's more than just a dollar value when you're hiring them if they're there months on end working in patients' rooms, or not patients, but residences' rooms.
All right, the next question is, I've submitted my assessment. Anything else I need to do before my life safety survey in May? At this point, I would say that you really just want to make sure that you have everything submitted. and going in there, and that really completing those assessments and having them in, and having that documentation that you have submitted, and that you are following the process is really the main key of making sure you stay in compliance and avoid any kind of penalties that might be submitted. Next question, I'm non-compliant and I'm required to complete engineering before we start bidding out our project. Do I need this?
Yes. I mean, that's a fair question to ask, right? Lead time becomes a thing. You're working a Gantt chart, you're looking for the longest lead time items and that kind of conversation. The challenge here is you don't want to buy anything unless HCI has approved it, and unless your local authority having jurisdiction who's going to be inspecting the facility is going to approve it, right? You'd hate to buy a X size generator when you need a 2X generator, right? Or you decide to buy an LP generator and they say, no, you got to go diesel, right? So you really need to get approval through HCI before you write a check for anything when it comes to buying the pieces of equipment. And HCI is going to require you to have an engineer or someone that's very familiar technically to put together a proposal for you to say, this is what I plan on doing. When it comes to the local, right? You have a local municipality that is going to be respectful or is going to be overseeing, they're called the authority having jurisdiction. They're the ones that are overseeing your construction site, right? So once you get everything approved through HCI, you now got to look at your local town to get a construction permit. And they're going to need full plans and specs. And the engineer is going to have to do all that. And you want to get their approval before you start writing checks and buying equipment, right? Because once you order a piece of equipment, it's a pretty healthy cancellation fee or change fee. And you really don't want to go down that road.
All right, thanks, John. And the last question looks like any updates on grants or reimbursements available?
I'm going to leave that one to you, but I'm not familiar with any at this point.
No, at this point, I do not believe there's any funding, federal or state, that is being provided for these projects. So at this time, everything would have to be self-funded. That concludes the end of our Q&A session. We'll now turn over to the product portion of the webinar. Thank you again, John Sharpe, for contributing your time and expertise today and helping out with the California SNFs and qualifying the project plans in compliance with AB 2511. As of today, only 58% of facilities have submitted their assessments. And of those 58% of the facilities that have submitted, only 97% of them are compliant. So don't feel alone throughout this whole process. There is a lot of facilities that will be going through this and working through and trying to get compliance over this year and multiple years to come, really, as these projects generally take 3 to 5 years. As a reminder, if you have not submitted your assessment, or if you have submitted your assessment, excuse me, it does not mean that you are in compliance. You're only compliance with AB 2511 when you have a letter stating for both HCI and CDPH that you are in compliance at that point. So to help it along, one of the things TELS can help you with is a front to back solution regarding AB 25 along with your generator project. Throughout this, the first step is really the qualification phase, where you sit down, discuss what your needs are, what are required for you to be compliant for this project, and really what is the overall intent. John did a great job in this presentation of going through all the different options that you can do, from generators of partial, whole house, and microgrid solutions. Once you've had that qualification completed and you've sat down, the next thing we do is we go through the engineering. We then we have an engineer go on site and start kind of putting pen to paper and creating the design that was discussed for your project. At that time, once engineering is finalized, you've written off saying that, yep, this is the route I want to go. It'll be submitted to your authority having jurisdiction and HCI for an initial approval. Once that approval is received, plans will then be submitted over to the authority having jurisdiction or your local municipality, whoever that may be, for the final approval so that the construction process can begin. Once approved, equipment will be procured and the construction can be scheduled. As John stated, lead times right now are longer than normal. Post-COVID, this created issues with microchips and other kind of supply chains for equipment. Um, Whereas before, it may be a yearly project, now it may be a multi 3 to 5 year project. Once your project is complete, lastly, you're going to want to think about your PM and service. You've just invested a lot of capital into a new piece of equipment, and you want to ensure that it has its longevity throughout time. Excuse me. So performing your routine maintenance as required by regulation and also just by manufacturer's recommendation will make sure that you have that equipment for many years to come. Next slide, please. As John covered in length today, there are many, many challenges in gaining compliance. The process we just discussed in designing and identifying those risks to mitigate them as soon as possible. The following are three of the biggest challenges we've encountered in previous projects. The first is documentation. You're going to need existing building plans, and if not, they're going to need to be recreated by your engineer. If you're going to go the whole building route and back up your entire loads, utility bills listing peak demands are going to be required to be able to size that generator appropriately for your facility. Most of these items are necessary to design the project, and sometimes it is worth it to gather that now instead of waiting later as you get further along down the process. Next is municipal approval. Plan review, permits, applications, lead times can vary from jurisdiction to jurisdiction. Some are very responsive, will take months to a year. Others in the area can take multiple years. Currently, right now, we're doing a project down in Santa Barbara, and we've been waiting approximately 3 years to get the permitting for that project. And discussed before, supply chain lead times are one of the biggest things that come once that project is approved. You now are waiting for that equipment to be manufactured and shipped to your site. Next slide, please. I don't want to spend too much time here, but if you're using TEL's platform, which is the #1 CMMS system utilized by senior living providers, you're already set up for success. Work orders, tasks, repair service, quoted work, assessment management, and capital planning is all about turning your action into data points that improve regulatory compliance, operational efficiencies, and reduce your cost to serve. Let your data do the hard work on behalf and subscribe to TEL's platform today. Next slide, please. In closing, all of us here at TELS appreciate the hard work you've done on behalf of California seniors. We consider it an honor to be part of your team. On behalf of our engineer firms, local installers, and Generac Industrial Power, we consider it a privilege to help you manage the AB 2511's compliance. Take advantage of our 30-minute free consultation. Call the 888 number on the screen to get started, or visit the web page below to request consultation via the contact form at the bottom. Take your time, do it right, and work with a partner like TELS to reduce the heavy lifting on your behalf. Thank you for your time today, and thank you for allowing TELS and Generac the opportunity to support you, your AB 2511 compliance. Have a great day.